An alternating current in amps is given by the equation I is equal to 0.0021 sine of 3t plus pi by 2, where the time is measured in seconds. Write down the values for the following quantities, including their units, and draw a sketch of one period of the current. Include the coordinates of maximum and minimum points and x-intercepts. Okay, the first thing we do, we find the values of the 6 quantities that we've been asked to find. By use of that information, we should be able to sketch the curve for the current versus time. I'll start with the amplitude. As you can see, the amplitude is actually equal to 0.0021 amps. We should make sure that we include the units for every quantity that we find in here. The next quantity I will look at is the phase angle. Phase angle. We note that the pi by 2 in the equation for the current has no units, or in other words, its unit is radian. Therefore, the value would be pi by 2 radians. Please note that you cannot replace pi over here with 180 degrees. And this is in fact 3.14 divided by 2 radians. Angular velocity would be the next quantity I will look at. Angular velocity. Okay, to find the angular velocity, we have to do a bit of calculation. We note that the quantity of the phase angle, pi by 2, has the unit radian. That means that, let's note here, that 3t has the dimension of radian. And since t has the unit of second, as mentioned in the problem, therefore 3 should have the unit of radian per second. Only then 3t will have the unit of radian, because 3t would be, the unit for 3t would be radian per second, which is the unit of 3, times second, which is the unit of time, and that gives you radian, which is the unit of 3t. Therefore, the angular velocity is 3, and it has the unit of radian per second. The next quantity I look at is the period. The period is found by the equation 2 pi radian divided by the angular velocity, which is 3 radian per second. This would be 2 pi over 3, and we can also simplify the units. Radian and radian will cancel, and we will get second. This is no surprise, because the period must be in the unit of time, and in this case it would be second. The next quantity I look at is the phase shift, which I will find by minus of phase angle, which is pi by 2 radians, divided by angular velocity, which is 3 radian per second. This would be minus pi by 2 divided by 3 is pi by 6, and we can also simplify the units, and we would get seconds. Again, no surprise, because phase shift is always in the unit of time, and in this case seconds. The last quantity I will look at is frequency, which is the inverse of period. and in our case 1 divided by 2 pi by 3 seconds. This would be 3 divided by 2 pi 1 over second, which is 3 divided by 2 pi hertz. Now, having found all these quantities, we can look at the graph of the current versus time. Time is in second and the current is in amps. Okay, we first start by finding the phase shift on the time axis. That's minus pi by 6. Let's say somewhere around here, minus pi by 6. This is one of our points of interest, so I make it clear that I'm interested in this point. Then we add to the phase shift, which is minus pi by 6, the value of the period, which in our case is 2 pi by 3. This would be minus pi by 6 plus 4 pi by 6. You can also use calculator at this point. This is 3 pi by 6, which is pi by 2. I also show pi by 2. Pi by 2 is equal to 3 pi by 6, so this length from here to the axis here must be 3 times the distance from the axis to minus pi by 6, just to make sure that the graph looks somewhat close to the actual graph. Okay, I erase the y-axis. Okay, now we need to find the middle point of minus pi by 6 and pi by 2. To find the middle point, you will have to find half of minus pi by 6 plus pi by 2. This would be 1/2 of minus pi by 6 plus 3 pi by 6, and this is 1/2 of 2 pi by 6, which is pi by 3, and that would be pi by 6. So pi by 6, it would be here somewhere in the middle, and that is pi by 6. Okay, now I need to find the middle point of minus pi by 6 and pi by 6. Obviously the middle point would be the 0 of the x-axis. Therefore, I will highlight that point. This is another point of interest. And now I look for the middle point of pi by 6 and pi by 2. To find the middle point of these two, I will have a half of pi by 6 plus pi by 2. That's a half of pi by 6 plus 3 pi by 6. That is 1/2 of 4 pi by 6, or 2 pi by 3, which is pi by 3. So the next point here would be between pi by 6 and pi by 2, which is pi by 3. Now I have the 5 points of interest. The typical graph for sine, the fundamental graph, looks like this, as you can see. So I'm going to create the same graph given the points that I have on the x-axis. The graph starts from minus pi by 6. It reaches the maximum at 0, and the value of the maximum would be the amplitude, which is 0.0021. Let's double check. That's right. And then the minimum would be 0.0021 with a negative sign. So the graph starts from minus pi by 6, reaches the maximum at x equals 0, again hits the x-axis at x equals pi by 6, reaches the minimum at minus 0.0021, and again hits the x-axis at pi by 2. This is one period of the function, and as you can see, the coordinates of all the interesting points are already on the graph. Suppose now we are interested in the graph of the function and the time interval between 2 and 3 seconds. Graph of the current on the time interval 2 and 3 seconds. This is not really part of the question which was asked here, but suppose you're interested in a situation like that, then you can find the answer by repeating the graph we have found along the t-axis. Let me reproduce the graph again down here. Let's say this is the t-axis and this is the current axis. Our interesting points were minus pi by 6, pi by 6, pi by 3, and pi by 2. Note that the distance between all these, and of course 0, and there are 5 points of interest, and the distance between any two successive points is pi by 6, which is a quarter of the total period. Now I can continue this graph, and the graph was in this form, where the amplitude was 0.0021. Therefore down here you would have minus 0.0021, and the current is in amps, time in second. Now to continue this graph, I would add again one full period to pi by 2, and I would have pi by 2 plus the period, which is 2 pi by 3, and that becomes 7 pi by 6. So let's say one full period, 7 pi by 6, 7 pi by 6, and then we would need to find the midpoint between pi by 2 and 7 pi by 6, and that would be half of pi by 2 plus 7 pi by 6, and that is 5 pi by 6, which is this point, 5 pi by 6. Then we would need to find the midpoint between pi by 2 and 5 pi by 6. That becomes 2 pi by 3. Therefore this point is 2 pi by 3, and we need the midpoint of 5 pi by 6 and 7 pi by 6, and that is just pi. Pi would be here, and the graph is, here is the maximum point and here is the minimum point, and the graph would look something like this. We can keep going in either direction, or the positive t direction or the negative t direction, to get the rest of the graph. But suppose we're interested in the time interval of 2 to 3. We note that 2 falls between 2 pi by 3 and 5 pi by 6, let's say somewhere here. let's say this is t equal to, and 3 falls somewhere between 5 pi by 6 and pi, and that would be here, t equal 3. So we can ignore the rest of the graph and keep only the portion of the graph which is between t equal to t equal to 3, if you're interested only on the interval, in the interval t equal to t equal 3. But we would also need to provide the coordinates of now these points. This is one important point of a new graph, and these are the, let's say, end points of the interval. If you're interested, we can calculate the value of I for these points. Let's say when t is equal to 2, I becomes 0.0021 sine of 3 times 2 plus pi by 2, which turns out to be approximately 0.0020 amps. And when t is equal to 3, I becomes 0.0021 sine of 3 times 3 plus pi by 2, which is approximately minus 0.0019 amps. And we can show this on the graph in this way. So at this point, the coordinates, the x is 2 and the y is 0.0020, and then the other point of interest is this one where t is equal to 3 and the current is minus 0.0019